Electrostatics. 1. What is electrostatics? It is the branch of physics dealing with stationary or slow-moving electric charges. That is, charges at rest. Key idea. Charges exert forces even when they are not moving, unlike current-based phenomena. Terms: conductor, insulator, semiconductor. For example, conductors allow charge to move freely, insulators don't. 2. Electric charge. There are two types of charge, positive and negative. Like charges repel, unlike charges attract. The SI unit of charge is the coulomb. C. Quantization of charge. Charge exists in integer multiples of the elementary charge C. Conservation of charge. In a closed system, total charge remains constant. 3. Coulomb's law. The force between 2-point charges, and separated by distance. F equals sign KQ_1 / Q2 divided by R2. Vector form. Force acts along the line joining the charges. Direction depends on the signs of charges. Repel if same sign, attract if opposite. Superposition principle. If more than two charges, net force equals sign vector, sum of forces from each pair. 4. Electric field and electric potential. Electric field at a point. The force per unit positive test charge placed at that point. F equals K, Q1, Q2 divided R2. Due to a point charge at distance. E equals sign 1 divided by 4 pi 0 Q divided R2. Electric potential, scalar, relates to field by. Useful for energy considerations. Note, I'll assume you know the formula for potential of a point charge. V equals 1 divided by 4 pi 0. Q divided by R. Field lines start on positive charges, end on negative charges. Density of lines indicates the magnitude of field. 5. Gauss's law and charge distributions. Gauss's law states that the net electric flux through a closed surface equals 1 divided by open A, 0 times the enclosed charge. Useful for high symmetry problems, spheres, cylinders, planes. Charge distributions, linear lambda, surface sigma, volume rho. For instance, surface charge density sigma equals Q divided by A. 6. Conductors versus insulators. In a conductor, in electrostatic equilibrium, the electric field inside is 0. Any excess charge resides on the surface. Insulators. Charges are more or less fixed in place, cannot move freely. Dielectric constant, relative permittivity of a medium. Equals open A divided by open A 0. This modifies Coulomb's law in medium. 7. Important formulas summary. E equals F divided by Q. E due to point charge. E equals 1 divided by 4 pi 0. Q divided by R. V equals sign 1 divided by 4 pi 0. Q divided by R, for point charge. Surface charge density. Gauss's law. FCED A equals Q enclosed divided by open as 0. Equals open A divided by open as 0. 8. Typical exam topics and tips. Be comfortable with vector directions, force, field. Sign matters. Use superposition. Add vector contributions of multiple charges. Use symmetry when applying Gauss's law spheres. Infinite planes, long cylinders.